Okay, alright, so moving on now. So this is the uh, practice problems from Chapter 7 dealing with the systematic treatment of equilibrium. And this was the one that you guys voted for, so this was number 3. And so, let's see what we got going on here. Okay, so what we see here, this is pretty much a real classical problem we have with systematic treatment of equilibrium, but we have a slight twist here, and that twist is we're trying to figure out what is the concentration what is the pH of the solution when the concentration of cyanide is half that of silver. Alright, so we add a sort of a defining term here, and so this set of equations should look familiar to you. We talked about these sort of ad nauseum in a Pogel exercise. Right, this is a sort of competitive equilibrium problem, and so so this is sort of by definition of the problem. We've set up another situation. That situation is that our silver is equal to 2 times our cyanide concentration. Okay, so what this is saying is that our cyanide concentration is half of silver, right? You could write this the other way. We said this is 1/2 equals that, but or sorry, the other way around. 1/2, yeah, whatever. 1/2 equals that. It will end up being the same thing. So right, so I don't know, maybe this seems counterintuitive, but in order for the cyanide concentration to be half of silver, by definition, 2 times the concentration of cyanide has to equal silver. Alright, so hopefully I didn't mess you up there. Alright, so what we're going to do, just like we do in all of our systematic treatment and equilibrium questions, problems, we want to write down all of our equations. So we're going to start with our KSP, right? We already have that reaction set up, so we just need to write down the equation that represents it, which we're given the value, and that's 2.19 times 10 to the minus 16. So it's our solubility product. We have, and that is our silver ions times our cyanide. Bing. Okay. And we have our Ka expression, which is Ka equals H plus times our cyanide divided by our hydrogen cyanide. Okay, and that equals 6.25 times 10 to the minus 10. We have our Kw, which is an old friend of ours at this point. So that's H plus times our hydroxide. And that is equal to, as we all know by heart, 1.0 times 10 to the minus 14. And then we can set up a couple things. We can think about our mass balance, okay? So our mass balance is, we know by definition that every time we dissolve silver, we're going to produce all the cyanide. So this would be basically your total silver must equal your total cyanide species. Okay, and so there's only one form of silver that we're considering here, silver plus, and that there are actually 2 forms of silver, or cyanide. We have our cyanide, and then we have our hydrogen cyanide. Okay. And we could do the charge balance. I don't think we actually end up needing that. So at this point, you can actually count up your equations if you wanted to, and you'll see that we really only have, let's see, we got 1, 2, 3, 4, 5 unknowns. Okay, I guess we technically have 5 unknowns, so we'll write up the charge balance. But you'll see after we do some substitutions, we won't actually need all these equations. So charge balance, and that's where you put all your cations on one side and all your anions on the other, and you bring down the charge in front of them. In this case, the charge on all of them is just 1, so we don't have to do anything tricky. So we got our hydroxide, and then our cyanide. Okay. Alright, everybody's happy now. Alright, we got 5 equations, 5 unknowns. Be a lot of algebra to solve that, but what we can do is we can make some substitutions, so we can try and plug one equation into another. So there's probably multiple ways you can go about this, but the way I went through on the sheet was I said, okay, we're going to try and get into a situation where we can figure out things in terms of cyanide. And so what we'll say is our HCN, right, from K. So this is from Ka, right? We know that our cyanide is related to our concentration of our H plus, our cyanide, divided by the Ka. In this case, that's 6.25 times 10 to the minus 10. All right, so again, that came from this guy right here. Okay, and so now that we have that, we can then plug that into another equation, right? And so this is from our mass balance. So maybe I'll use a different color since if it will let me. There we are. All right, where are you? So in this case, let's use our mass balance, which is this one down here, which is personally one of my favorite equations. So so our mass balance we get this relationship where our silver equals our cyanide plus our hydrogen cyanide. We know from this equation we can plug this into there. Whoopsie daisy. And so I'm going to just write this down. So this is H plus cyanide, no space here, divided by, I'm just going to write Ka. And the next thing we know is that by definition of the problem, our silver equals 2 times our cyanide concentration. What? Okay, so if you remember that, that was by definition of the problem here. Right, and so we're able to use the conditions that this problem sets up to be able to solve it. Okay, and so we can put this equation down here. The full equation ends up being our cyanide, 2 times our cyanide equals our cyanide plus this expression here, yada, yada, yada. .25. So this, the reason I went this route, and I said you can go to a different route, you should get to the right answer no matter what. But the nice way here is that now we have cyanide in every one of these expressions, and so if we divide everything by cyanide, we can get it out of the whole equation, and then you'll see that all we have left is this one variable H plus, which again was what we were trying to solve for. So I'm going to divide by cyanide, right? I'm going to divide this by cyanide. Alright, I'm going a little crazy here. Try and write like a human. Alright, divide this by cyanide, then divide this by cyanide. And so basically what happens, let's use a pretty red one. These cancel, cancel, cancel. What we're left with, I'm going to write it on the next slide, is, where are you? Left with then is just 2 equals 1 plus our H plus over our Ka. And I'm going to write the Ka in at this point, so that's 6.25 times 10 to the minus 10. Rearrange this, and you end up with essentially H plus equals 6.25 times 10 to the minus 10. So you see we subtract 1, multiply by 6.25. Now if we want to find our pH, we just simply take the negative log of that. Alright, and that gives us our pH, which ends up being 9.24. So there we go. So hopefully that showed you guys. This is one of those situations where you try and use all the information to your advantage. And again, there may be a different way you could go through if you're doing selected different equations to make different substitutions, but you should be able to get the right answer either way. This probably is the most efficient way, but there could have been another way that might have taken you a little bit longer. Okay, so it may be a little bit till I record the next one. I've got a phone call to do, so it may be closer to, let's say, around 7 o'clock that I do that last one. But I will post it then. Okay.